good here. It just tends to go up and down a bit. So if you have got any devices which are tuned into the Google Wi-Fi, it would be really helpful if you could switch them off to this meeting.
Sounds better.
Is that okay?
Yeah.
If we're ready. Yeah, when other people are speaking as well, if you can try and stay in this area so that microphone can pick you up, and anybody watching online should be able to hear you.
Okay. Okay, well, hello everybody, and a big welcome to Google Campus and Crocodile Launch. And also a big welcome to the people who are watching this online. A big thank you to Randy Resnick for organising the stream for us. I think this is the perfect venue for this because it symbolises completely the move from telecoms to the web. This area around here was always a big telecoms area. It goes right back to the post office, BT, there's a telephone house around the corner. And I knew the area very well in the 90s when I worked for Ericsson, working with a lot of new telcos starting up in the UK as a result of deregulation. So it's got a telco background, but as you all know, today it's part of Tech City and it's part of the internet revolution. So, you know, we see this big change that's been happening, and Crocodile was launched tonight, part of a move away from the old telecoms industry and into the new web and internet industry. So, what's on the menu tonight? First of all, I'm just going to take a few minutes to introduce you to WebRTC. I'm very aware that in the audience we've got people who've probably hardly heard of RTC to the real biggest experts in the world. So it's a bit hard to. So the technology slams will get deeper as we go on. So I hope you will bear with us. It gets a bit much. Peter is actually with some whiteboards. You may not be able to see it, but there are the sticky whiteboards stuck onto the walls here. When we finish the formal part, Peter is going to stand there with his pens. Anyone who really wants to get down into WebRTC technicalities can form their own group in the corner, going through the details. So, I'll just say a few words of introduction to WebRTC at the beginning. But the real purpose of tonight is to announce Crocodile's product, our offering, which are in three parts. First of all, the Crocodile network, which is a global cloud-based signaling network. The second thing is the Crocodile SDK, which is the way in which app developers get access to the network. And finally, we're going to look at one particular WebRTC application that we've written, we call Crocodile Talk. We don't intend to be in app business, but we thought the best way to prove how good the SDK is to write our own applications so that you can actually see how powerful it is. And our intention actually is to open source all of the applications we develop, which hopefully will encourage other app developers to use our SDK and to develop all sorts of wonderful new applications using it. So that's the Crocodile part. Following on from that, we've got three very good speakers. Ashley from New Voice Media, actually the founder of New Voice Media, and a real pioneer of cloud computing. We've got Glenn from Amazon Web Services. As you'll later, we're big users of Amazon. The network is based on Amazon. So I'm very happy to have Glenn here to support us. And finally, Jean from Novisense. We use a lot of open source, well, a number of open source projects within the network. SDK. And Jean is the lead for the MobiSense, which is a SIP serverless system. So those three speakers, there will be the opportunity to ask questions to each of them. I think we'll try to keep the questions fairly short because I think there'll be plenty of time to talk at the end. So then I'll make a few closing remarks. Hopefully that will take us up to about soon after 7:30 when the food should arrive. And we'll be able to back in and do drinks and continue the system there. So, what is WebRTC? It's a new standard promoted by W3C, and it gives an API to the web app developer to allow them to set up audio streaming, video streaming, and or a data channel between two browsers. So one browser talking directly to another browser with nothing in between. It's first appeared in the final quarter of last year in Google, in Chrome, and it's been progressively improving within Chrome, and has now appeared in Chrome for Android. Mozilla are big supporters of WebRTC, and I think just this week Firefox went to beta. It's in the beta version of Firefox previously, being a mighty version, and it's in Opera. And Google just announced a couple of days ago that they're providing a native Java and WebRTC toolkit, which means that you can use that on Android, but most importantly, it'll bring WebRTC to Apple devices using iPhone. So, this, according to Google, in their conference this week, there will be 1 billion WebRTC enabled in the next few weeks. So it's out there. The WebRTC enabled devices are out there in use. It's worth looking at the reasons why we think this browser-based approach is the future, because we live in an app world, which means people are used to downloading apps from App Store. But the problem with apps and with all the differences between the different devices that are all running on is going to be overcome by the browser approach. So the browser approach gives us a single platform, a standard platform which will run all devices, and no separate operating systems for each device that you have to cope with, but just a standard set of capabilities and APIs that the web app developer can use. This makes it much quicker and easier for developers to get their applications out there, and they don't need to worry about new devices with new operating systems appearing. They know that they've just got one line to develop.
It's from like times in the projector.
I thought it might be an EMC effect.
Yeah.
Okay, so the browser gives a rich environment. There's a lot of capabilities that have been built into the browser already, which are being used, in HTML5, becoming more and more important as a platform for gaming, and the WebRTC capabilities are adding to this capability, the rich environment with the browser. The browser is always up to date because it's downloaded each time. You always get the latest version. You don't need to worry if you've got the latest version of an app or not. You know the latest. Invites as the App Store. It means that the developer, the web app developers, don't need to use Apple or Google's stores to sell their products. And perhaps the final and perhaps the biggest advantage is context. It means that most of what we do these days is done from the browser. We browse, we visit sites. As a result, information is available. And that contextual information is available to be transmitted to the other end, which should mean a much closer sharing experience between two or more parties call of a session. So these are the benefits, and this is what's driving the move to the browser. So WebRTC, in one way, it's an evolution. It's different from HTML5 and moving one step further. But a lot of people are saying and thinking and predicting that actually it's a revolution, that this has really changed the whole concept of communication. And it brings me to this point that we're moving away from the common era and into a new era, which is web applications, cloud communication. So these are the kinds of quotes which various people have been making just in the last week that I've seen. Communication is real time, just by loading a web page. Voice is just another JavaScript application. Developers can build great experiences. We'll create new communication. Maybe it's hype and maybe people are going fast, but really I think there's absolutely huge potential. Thanks for the time. So what are these wonderful applications that people are going to make using WebRTC? Inevitably, the first ones that are appearing are based on applications that we're already familiar with. So, the equivalent of Skype, for instance, just using the browser as a way of accessing existing telecom services. But really, the next step and the next wave is around collaboration. We've had unified communications is a big thing that everyone is used to, but taking it further, anything to do with getting people to talk together and share experiences is right for this. So we've been involved in a few events around here, and for instance, I've met at least 3 different startups working in the distance learning, remote education sphere. They're all very interested in using WebRTC, building WebRTC into their basic proposition. Medicine is another area. Obviously, there are great possibilities for getting experts talking to the patients over distance. It's hard to get the people together. The more you can do things from distance, the more information and richer experience it can be, the better it's going to be. Gaming is another one. More and more, there's more and more interest in building communication into games. But there are other things as well, like the Internet of Things. I think you're probably all familiar with the forecasts for the number of devices which are going to be connected to the Internet over the next years. And so many of those devices will have video capability, for instance. So things like home security is an obvious one. And it may well be that people developing the applications will take the browser-based approach, even though one end is not a person but a thing. Still, it looks like the browser is a better development platform than the operating system. And finally, people are very interested in the idea of using the data channel which is built into WebRTC as a mechanism for facilitating peer-to-peer data connection. Products for sharing streamed video and so on. So we get a lot of different directions that we think WebRTC is likely to go over the years. You know, which one will be the biggest is hard to say, but you know, it's going to be interesting finding out. But WebRTC is not enough. As Google themselves admit, you need to do interesting things. You need to be able to do more than move data from one place to another one. And I think a lot of us involved in the telecoms industry realise that the various protocols that we've developed for doing things like setting up telephone calls, sharing presence information, sending messages, and so on are all needed. We call this signaling, and signaling is needed for discovery. The two endpoints have to find out that each other exists and have some way of addressing each other and connecting to each other. And signaling is the way of doing that. Sorry. Maybe you can move a bit closer to the front. So we have WebRTC and Google and Mozilla are doing their bit, but we want to do our bit as well. We think that it will be very helpful to have an open and free signaling network which can work alongside WebRTC and will allow the app developers to really get the most out of WebRTC. So that's what we've developed. The first step, the first layer in the Crocodile offering is an open, scalable, global signaling network supporting SIP protocol, XMPP, and MSRP initially. It's not that we're particularly tied down to those protocols, but they seem to be the most useful ones to develop first. It may be that new protocols will emerge, but hopefully through our SDK we will hide the complexities of those protocols from the app developers and make it very easy. So it may be that one protocol is better than another, but if the developer has just used, but probably the API doesn't need to change. So we can seamlessly change the protocol at the lower levels without the app developer needing to know about it. Hopefully our SDK and the APIs will be simple enough for the app developers to get started without needing to know any of the complexities that are going on below. And finally, we're developing some sample applications. The first one is Crocodile Talk, which is a kind of, I hate to use the term, but it's a Skype-like service which allows you to make voice and video calls, to do instant messaging, to do file transfers, and so on. And it'll be linked to the PSTN so that people will be able to make cheap international calls. We're not trying to take on Skype ourselves, but we do see a big demand for these kind of applications from, for instance, the internet telephony community. So this stuff is pretty difficult, and a lot of operators don't have the capability to do it themselves. So we think we can help them to get started, and they can be on network. So we'll be white labeling the Crocodile Talk service. But and second application is a basic tick-to-call service. Okay. We were going to go into the demo, but I don't think the demo is going to be quite ready.
Yes, but it's okay, because I can do a little bit of explanation about what's going to happen in the demo.
Okay,
So.
good. Can we ask questions?
Of course, yeah, just
Ask questions now. Very good time while the demo's.
Yeah, can you just clarify that? So basically, WebRTC, which I'm not aware of, browse, running normal around and direct usage.
Yeah.
What you're basically saying is Crocodile provides a platform for system control. So if I want to talk to Joe at the end, I can look for address, Joe, or
Yeah, so, but basically, using the SDK, the first thing you'll do when you go to your browser is be registered on a single server. And the other end will also be registered. And so then there's a path between the two that we can join together. I mean, really, it all comes down to IP addresses. You need to know the IP address where the other browser is. So that mechanism gets that information into your browser, so it knows where to send that information. Yes, in exactly the same way that any phone network, fixed or mobile, has a network. You're probably aware that the mobile operators are moving to IMS. That's the latest network side. It was nice when it stopped. We are using the same protocols. IMS is based completely around the SIP protocol and other protocols like diameter, which we are implementing within the SDK. It's a big debate amongst the mobile operators about how they often talk about opening up their network and allowing developers to have an API to the network and allow developers to get access to the network. There's been a lot of talk that's been very, very slow in happening. By taking this approach, it's there. We're enabling it. Effectively, we're providing a network, and the developers can get stuck in, use the simple APIs, build them into their applications.
So nobody else has built any infrastructure for you, RTC. So nobody else built any infrastructure. In the same way as Crocodile.
There have been some very small scale SIP-based networks made available, but nobody has done it in a big, secure, and scalable way. We think we hope that we'll be doing WebRTC industry a big service by making this available, and we've built this on an architecture which is scalable, and the core components are very low cost. So we're confident that we can provide capacity which all the different applications are going to need to make applications run.
What is your commercial model? Do you come to that, or is now a good time to do that?
Can we come back to that at the end, because that's really what I was going to address.
Just a sort of basic question. The browsers have to be the same type, or is it just the browser?
No, the whole beauty of WebRTC is that it's standardized. WebRTC is standardized, so all the browsers can talk to each other.
The browsers need to be connected to your system where actually communication happen, or is there some roaming or absolutely connection?
Well, the application which is running in the browser, the web page, if you like, the developer of that web page can use the APIs which will enable it to talk to our network.
We'll come back to talking about that. We're having a technical session at the end. We should address something like that at that point.
Of course. Yeah.
Regulation by law from size. Where's the specific regulation laws when it comes to security and privacy and things like that? Are you regulated the same way you are from, or are you?
Well, we're I suppose the equivalent of Skype. Yeah, I mean, to be honest, the technology is running ahead of the regulation. I mean, if you're honest, what we're building is completely secure and encrypted, and actually, there's no way of knowing what's going on in the endpoint. That's inherent in WebRTC.
How is all
Well, the problem is with WebRTC is that the browser has some certificates at the end and they encrypt the media peer-to-peer. So unless a network specifically receives that media and decodes it on media server, which would be, if somebody wanted to do full interception, would ultimately be the responsibility of somebody using our API rather than us, is encrypted end to end. You don't have control over that. That's what the W3C and the IDF standards have done. They have mandated end-to-end security.
I think you should stop that.
So,
This debate is going to run.
Yeah.
That way. One more then.
There's a couple other companies that are doing APIs and SDKs. Not quite the same as that. Are there going to be interoperability problems, or we get end up with a Crocodile and a bunch of other islands?
Well, we aim to be completely open, so we will appear at the set level, for instance, not federated, it's the equivalent for XMPP. So anyone will be able to call someone who's registered on our network by calling the SIP address. It's probably not the time to go into the SIP address, but the SIP address is actually identical in format to an email address. So from the Crocodile client, you'll be able to put in the equivalent of an email address to call somebody else who may be on our network or maybe on the network.
Everything will be standards-based that we're doing. So although other people are doing proprietary stuff, as long as they're able to convert something that is standard-based, they can interconnect with us.
So we aren't going to compete with Skype. Crocodile Talk is competing with Skype as part of what we think will be a new ecosystem of equivalent companies who are also providing open networks. And all of these open networks together will be the equivalent of Skype. One more then.
So how does someone support process environment?
Okay, let's have a technical discussion because I can answer that. But yes.
Yeah, there's a lot of effort going into that. Okay, we're ready to demo.
Okay, so just to quickly explain what we've got there, I'm logged into. You switched to the stream. Yeah, I'm logged into the Crocodile Talk, what we call Crocodile Talk communicator. So this provides the ability to make audio and video calls using SIP signaling. It can exchange presence and instant messaging using XMPP. We use MSRP for file transfer. So we've just got a little bit of a fun demo here. What I've done, when you first load the client, it takes over the default handler for tel and SIP URIs. So we've got a website which is
okay. So there's let me introduce Jeannie Jan, psychic extraordinaire. She specialises in disruptive technologies. So Dean, you're David. So we're going to give her a call. I've got a few questions for her. I've got 3 questions for her, and they increase in difficulties. Don't forget, we're calling to the spirit world. The communication, they do have Wi-Fi, but it can go up and down. So it may drop out and come back, but let's see how it goes.
okay. So I come to this website. There's this psychic I want to call. So I click on her, and this pops up. I get the opportunity to make a call without having to dial. And we're calling.
Oh, hello, Jeannie. Jeannie Jan, how are you?
I've not been putting off at all.
You're not too good. Why is that then?
Oh, it's been awful. I bought a lottery ticket. Of course, I predicted all the winning numbers.
Okay. told you she might sort of go in and out a little bit.
I bought a lottery ticket.
Yeah.
And I thought it was my Christmas balls. I got all the right numbers.
Well, that's fantastic. Why aren't you happy?
No, because I don't know where it is.
Oh no. Anyway, the communication is going a bit wobbly. I'm going to ask the questions quickly. So first of all, first question, easy. Who is going to be the next manager of Chelsea Football Club?
Oh, actually, who's entering you?
Yes, you're pretty sure. How come you're so sure?
My crystal ball tells me everything, and besides, I read it in some newspapers this morning.
Oh, it must be true. Okay, next question. What do you think the weather's going to be like this summer, Jeannie Jan?
The summer this summer is going to be very interesting. Oh, that's interesting. And the weather in the summer of 2027.
Not as interesting as 2027. It's a bit enigmatic, but... Okay, finally, the big question, the really big question, the $64,000 billion question. Which codec is the IETF going to choose as the video standard for WebRTC?
Ah, very interesting. I see in my crystal ball, I see an H, or it could be a V. I see the number 6, or it could be an 8. I see many things. I see my winning lottery tickets. I know where I left it. I'm going to have to go and collect my video.
Oh, no, give us the answer, Jen. Quick, give us the answer. Sorry. I think you get the idea. Yeah.
Oh yeah, sorry. One other quick point before I disappear. Just in case you didn't notice, that was a premium rate call. My balance has gone down significantly.
Just as a
because
result
of not getting much information at all.
So now Peter's going to just go into a little bit more technical detail about what exactly is behind the network.
Okay. So, as John said, we're producing an SDK and a network. So the SDK, the long story, we've also wrapped a number of very good JavaScript signaling stacks. On the network, we're using a lot of open source equipment, and so I'm going to just discuss it a little bit now. So we really split the network and the SDK into four components. We have the Crocodile SDK, which is a wrapper across the JS SIP stack, the JS XMPP stack, and the Crocodile MSI stack that we've written. The purpose of this wrapper is to provide a really simple but unified API. These are all very excellent signaling stacks, but they all work in slightly different ways. They all have APIs that aren't the same, which makes it somewhat confusing for a developer who doesn't understand the signaling. So our primary thing was to have something that allows you to set up a SIP call or do even a file transfer with only half a dozen lines of JavaScript code, without the people using it having to understand how it works. It also, the SDK also talks to our web service. Our web service is what allowed us to do things like get the balance. Our web service also involved the authentication of these WebSocket calls. And it can be accessed from third-party websites. If you want to write a third-party website that allows people to sign up for your service, create accounts, to change passwords, even to use PayPal to top up that balance on your account, the web service provides that integration. At the network edge, 1 minute.
So we have to do this because there's a lot of people watching on the streaming, and we'll give them time to look at different multiple site pages as well.
Yeah, no problem, just leave you. That should be on the slide.
fine.
Nobody really wants to see that. Absolutely guarantee nobody to come to see it. Okay, so on the network edge, everything connects to the network edge through secure WebSockets. All your signaling is safe, all your signaling is secure. And for SIP and MSE, we use Crocodile. For XMPP, we're using the Node XMPP ball. And we also, inside that edge of network, have a Tor server. Once a traffic comes into the edge, there's all sorts of authentication on the WebSocket traffic to make sure that traffic's allowed. Sites it's allowed, sites are routed. And the network edge has two choices. Either decide that the traffic belongs to a domain that's local to our network, and we want to get routed into our network core, or it can decide that the traffic belongs to somebody else because and route the traffic onto them without it. So the SDK provides an easy-to-use API and to basically to enable rapid development of these lists. You can do this as your imagination. You could have a game doing all sorts of advanced graphics and web. You could integrate there. You could have a online poker game. You can actually see the faces of the people that you're playing, and it's using MSRP WebSocket to exchange data with the server over what card being dealt. There's all sorts of things you can do. Actually, the SDK it interacts with our web service, it maps to client stack, it maps to next client stack, it maps to MSRP client stack. The web service, it's a standard web service access over HTTPS, and it's a JSON API for provisioning management. The SDK uses the web service, but so can a third-party website. We have a SIP edge proxy, MSRP. All the actual signaling traffic is over secure WebSockets, and these secure WebSockets connections are authenticated ways, and I can adjust that later. Any traffic we host on domains we host is routed into the network core, and we're perfectly happy to host domains for other people. So if you don't want to build a SIP infrastructure, you just want to be able to have phone calls coming into your domain, we can host that. But if you want us to have your own domain, we can at the edge route that traffic, that XMPP traffic or SIP traffic, into your network. And from that point of view, it will appear just like another interconnect. The same way you can get traffic from BT, Gamma, Gradwell, you receive traffic from Crocodile. And what this allows you to do is make use of our WebSockets, and our security, our expectation to provide another access into your network, another secure access into your network. And to you, we would appear to be just another interconnect. Within the network core, we have a SIP proxy registrar, XMP server, WebRTC, a PP application server, which is built on MobiSense SIP certs. We have a billing server, which is an application called JBilling. MobiSense diameter as the diameter server on there. And this network core, it only accepts network edge. So with this network is scalability. All traffic into the network from side and it's return server, keep indication, thorough credentials. You don't actually have to embed passwords into your JavaScript application. It will interact with the web service to generate unlimited expiring credentials that will just work on these services. And we've deployed this on a multi-availability zone deployment. So we're using EC2 servers with an RDS Amazon RDS database on the back end. We're using SES, the simple email service for outgoing email relating to the system, and we're using Route 53 for all of our DNS. At the moment, we just have the Turn server and SRP relay one data center, but we will be deploying those around the world, and at that point, we will be using the Amazon Route 53's latency-based routing, which means that the Turn server you use will be the one that is the fastest for you to use wherever you're in the world, critical. We are using Elastic Beanstalk, which is Amazon's web service deployment tool, right now for Manager, and that provides scaling. And we are going to be moving the API application server over to that as planned. We'll also be hosting all of our websites on there. At the moment, some of them are hosted in different places, but we will all be going onto that platform. And as the network grows, which we hope, or we plan for this network to grow very huge, a traditional SQL database is not going to be enough. So we have plans to make use of Amazon Elasticache, which is a hosted distributed memcache for data. We want to use their DynamoDB, which is their NoSQL database. And at the moment, we're doing logging of signaling. We can continue doing that, which enables diagnostics, CDR generation, and lots of other things. And we will be putting that into their Redshift, which will allow that to be archived for a very long time and searched in a secure way, allowing that data to be mined, which we think is going to be very important because people who implement services on this form will want to be able to do some form of data mining and analysis to find out how people are using it, where are they using it from, what time of day are they using it, how long are they staying on for. And they want to see that over time. If they make a change to their application in the future, they can actually see what effect that has. Has it increased traffic? Has it decreased traffic? Do people like it? Do people not like it? And so that's just a little bit about the technical side of what we're doing.
Question, because one thing will lead to another if we do. But as I said earlier, Peter is going to be available to go into as much depth as you'd like to do as we're finished. So I think you've got the idea of what Crocodile is offering and the network, the SDK, the application. We aren't doing it in isolation. We very much feel we're part of an ecosystem, and we have a lot of friends that we're working with, partners that we work with. So I thought it was only appropriate, really, to invite some of them to join us tonight. 3 of them, in fact. The first one that I'm going to invite to come up and say a few words is Ashley in New Voice Media.
Okay. So thanks for the introduction there. So I'm Ashley, I'm CTO and co-founder of New Voice Media, and I just wanted to take us to a tiny bit about New Voice Media, and more importantly, why we think WebRTC is important to us and where we think it's going to go. So to kick off media, we're a UK-based company. We provide cloud contact center solutions to companies around the world. We provide all the technology you need to run a contact center. All our customers need to do is to give their employees a web browser and a telephone, and we do all the rest. What really makes us different is that we provide a very reliable service, a very secure service, and a very flexible service. Our big driver is to enable our customers to provide the best level of customer service. So we use it to provide intelligent routing of calls, of emails, and web chats. We connect the right person to the right agent at the right time. So how do we think WebRTC will change the way that customer service is provided? And how do we think it will change the wide world of communications? We believe that there is a possibility that WebRTC will drive a real revolution in the way that we communicate. There's an awful lot of experimentation currently in this area. We're doing a lot of experimentation. A lot of other companies are doing experimentation. And it's kind of difficult to work out yet where things are actually going to go, how they're going to work out. I just wanted to take you through some of our views and how we see things going in the future. So if you look at telcos today, you see that they do two main things. They provide the infrastructure over which we communicate, and provide universal addressing schemes. Provide Now, we think one of the very important things about WebRTC is that for a lot of applications, there is no longer a need to have a universal address. Each application can have its own addressing scheme, which can often be invisible to the user. There was a very interesting discussion earlier on about how to operate with Skype, with telephony. I think our view is that that's important and that's good, but there is an awful lot of applications that don't need that. This is not, I don't think WebRTC is about replacing Skype. It's a whole lot more than that. It's about building rich communications into different websites, into different applications. We think we can build, there's going to be an awful lot of very rich islands of communication. So this is an example which was very principal earlier on. This is a website which is really not just as a demo at the moment, where two players can play chess over the internet and use WebRTC to have real-time voice and video communication between them. And we think there's going to be many more of these types of applications that can embed communications using WebRTC. We also think, as Crocodile have shown, that there are many changes that can be happening on the infrastructure side. There is a real scope to separate the signaling and the transport much more than is done today. And often, for a lot of applications, we can simplify the infrastructure. One of the very important things about WebRTC is it allows us to use the right channel for each communication. Often, it's better to use voice, sometimes chat, sometimes video, sometimes just pure data. And it's often the case, depending on the application, that you have a mix of these channels. WebRTC makes it easy to do this, and it makes it easy to flow from one channel to another. We also believe that WebRTC is very important for video, as we finally have a low-cost, open, and ubiquitous method of video communication. And this could be the real push that video needs to make it a commonplace method of communicating. Especially important for us as a company is WebRTC gives us access to real rich sources of information. We live on the information we can gather about our communications and about our agents. This opens up more possibilities. We can get access to browser history, page views, user data, all before the communication actually takes place. And we can also tap into the rich analytics that are already available on the web. This means that we can provide even better levels of customer service by getting rid of data re-entry, having to put something into a website and then talk to an agent, repeat your details, getting rid of that. By providing even better intelligent routing than we currently do, and providing this seamless communication. So what are our plans for WebRTC? We plan to implement it, integrate it with our existing web chat products, so that we get access to these rich sources of information, and we can provide seamless from chat to voice to video and back again. We also plan to integrate into our agent experience so that we can get even better location independence and potentially, in a lot of cases, remove the need for our agents to have a telephone. They can be purely browser-based. And we can also provide end-to-end video communication into the contact center. So, we think a real chance WebRTC can provide a revolution in the way we communicate. We think it could be the spark for Cambrian explosion, new ideas, new ways of working, new ways of communicating. I don't think any parties are going to work out yet, but I think about it. These guys are very excited about it. I think you should be very excited about it. Thanks.
I think we've got time for maybe
Just quickly, before we do that, we have a request from online, which is, can we show some live people? So before Ashley answers some questions, if we can get you to switch back to the webcam and ask Ashley to move in front of it, then people can ask questions.
Could
you repeat the question?
Yeah.
Oh. any questions?
I just switched over to you. Yeah.
Yep.
You're saying video contact centers.
Yeah.
You give examples of what could be done or not be done already?
So a lot of it could be done already, but it hasn't really taken off. And I think it's because of the expense of current solutions and just the lack of having a constant stream of doing that. I think video could be very useful. It doesn't necessarily have to be two-way, but it can be useful, particularly from the agent side, to be able to give better explanations, potentially to either be able to show things or to play instructional videos back to the caller. So a lot of the capabilities are arguably there, but there hasn't been that ubiquitous means of doing it. And it hasn't, the way it's been there hasn't, it's been really expensive, really difficult to do. Sorry, for the people offline, the question was what is different with video in the contact center these days and how can you do that?
Okay, thank you. Well, there'll be plenty of opportunity to talk to Ashley again. I'm sure it'll be. So thank you very much, Ashley. I appreciate you joining us. So next up is Amazon. As I mentioned, Peter mentioned, we're big users of Amazon Web Services.
Yes. So we'll just wait for you to thoughtfully switch back to the slides.
There you go. Well, good to go. Cool. So, I've heard a lot today about disruptive technologies. I definitely feel like I'm in the right place. For those who may have not heard of this, what do we do? Well, infrastructure services over the internet in a pay-as-you-go, on-demand fashion. We use this elastic model, which enables customers, Crocodile, to go scale up, to use our data center processes around the world to deploy their infrastructure, without having to worry about doing that themselves. I'm here to talk about that. That's one of the core benefits of using any sort of cloud service. I'm going to talk about and again, it's a common thread tonight, talking about APIs. I'm not going to talk about the API specifically. I'm talking about the business value that we see our customers getting out of APIs. Maybe more importantly, an API around these infrastructure services means you've got a programmable data center at your fingertips, which means that this elastic model allows you to deploy infrastructure in a just-in-time model to meet your demands of customers. They change and fluctuate, potentially on a global level. So that's what in itself. A programmable data center means you've got something that's completely auditable, which now means you haven't got that undifferentiated heavy lifting, having human beings having to do that for you. Your applications can dynamically decide when they need to deploy infrastructure and do that on your behalf. They can recover from failure and meet current demand. Again, in itself, that's a really cool feature that our customers take lots of benefit from. I'm not going to
quite talk about that. What I want to talk about is continuous deployment and the sorts of conversations that I have with my customers, and then also the way we embrace this at Amazon and the sort of business benefits we're getting from this. So I've made a statement here: continuous deployment at Amazon means small, frequent changes continuously integrating into production. So when I talk to customers, the word that it says in the most is production. I say, Glenn, how am I going to take our team of developers and let them loose on our production environment, deploying our code straight in that environment? Surely it will break loose. Well, the interesting thing is Amazon do exactly that. So I'm going to quickly tell a story about how we're able to do this and using this disruptive technology. So at Amazon, we've got this rule. It's called the 2 pizza rule. It means that any team in Amazon can only be as large as it takes to feed using 2 pizzas, which means that these teams themselves are very small, discrete units. Now, hold that thought for a minute. If you imagine the Amazon retail site, there's essentially constructed of 4 main services. We've got a search service, you can search for products. We've got a recommendations engine, which is going to show you products that are relative to your buying habits. It's got an advertising service as well, which shows you different information down the side. So if you take the recommendations service on its own merits, it's not a single service. It isn't one software stack that we're deploying and making changes to. In fact, Amazon uses a service-oriented architected approach, which means that we're using lots of very, very small, discrete services making up this largest recommendations engine service. So the important thing here is these 2 pieces of teams, one team will manage one service. So why is that important? Well, first of all, it means that our teams are responsible for designing these services. They're responsible for building these services and also responsible for managing these services. So when things go wrong, these are the guys that get out of bed, these are the guys that get paid. So it enables us to make much better design decisions up front. And also around these services, because we're keeping them small, we're keeping the teams that manage these services small as well. We're doing what we call limiting the blast radius. So when failure occurs, it only occurs within that one service. These services are loosely coupled, they have no dependencies on each other. And in fact, when we design and build these services, we're designing for failure. It's an important tenet of cloud computing. When you design your applications and embrace it, you embrace failure. So what that actually means is these discrete individual services. If our recommendations engine wanted to talk to our authentication service as an example, it doesn't make any assumptions that it's ever actually going to get a response back from that authentication service. It's waiting for a security token, it makes a request, it actually assumes that it's never going to get a request back, which means that within that discrete service itself, we've got the ability to handle that failure in a nice way, rather than an ugly way and display an error message on the screen. It's also going to limit the blast radius of that failure. It's not going to get upstream or cascading failures as well. It means we can have short circuits, it means we can have failbacks. Instead of not being able to get a security token back and generate some recommendations based on your login, it might just provide a static rendered HTML page to the user instead. So it's giving a much better user experience. And lastly, all these services, we've heard about APIs tonight. So all the AWS services are exposed by APIs. And all services that make up Amazon.com are also exposed by APIs. What does it really mean? It means that the engineers working on these services, these small teams, get to focus on the technology. They can use any technology they like because other services that are dependent on them are completely abstracted away from the underlying technology. So other people don't care if it's a Java stack running on a JVM, they don't care if it's a Ruby stack running on Rails. The engineering team who run that service can choose the best technology at that moment in time to bring back business value. Other services, they call an API, they give a request and they get a response. It's those 2 things that need to stay consistent and nothing else. So these things as a whole, these small isolated teams, these small isolated services that have almost no dependency on each other, enable us to innovate, make best use of underlying technology. And to give you some stats on how that actually works out at Amazon.com, these are stats actually from last May. This is production deployments into the Amazon.com retail stack. Per hour, we had 1,079 deployments on average, which meant we were deploying in every 11.6 seconds. On average, around 10,000 nodes and a maximum of 30,000 nodes. rate of innovation, the deployment velocity we've got is because we've built our business in such a way that we've got these very, very small discrete units where these guys, these engineering teams are able to innovate at pace. We've removed the constraints around failure. Before, failure would normally mean that the whole platform would become unavailable, would be given a bad user experience, and the developers weren't able to really sort of unrelease these constraints and just go and innovate. So what we're seeing now, this continuous deployment model that we use, is really about continuous experimentation. It's releasing those constraints, allowing our developers to innovate, to come up with great new ideas and new solutions to existing problems. It means we're seeing continuous improvement, but when we don't see that, when things break or fail, they're done in such a small, discrete unit that it doesn't take down the whole of the website. And other services are built in such a way that they're able to deal with that failure in a graceful manner. So when I talk to the developers who work for Amazon.com and also developers who are embracing the AWS platform, they're using these APIs, they're designing for failure, and fundamentally they're able to innovate, they're able to bring disruptive technology into new markets in a very fast and efficient manner. And if you want to find out more about that, which I described, me and my colleague Anwar will be around this evening to join you for this. So, thanks for your time.
Well, we've been told we want to see human beings. So.
Okay, any questions?
Yeah, I've got a question. As a major provider of web services, obviously with customers such as Crocodile, when and how are you going to be using WebRTC to do your own customer care or other functions?
Interesting. So the question is about when are Amazon going to be using real-time communications to service access?
Yes.
So we already have, so I can't think our use of Crocodile RTC as a product itself. I'm not involved in those conversations.
WebRTC as a technology, you guys ought to be in the front line.
Well, yes, we'd like to think. So Amazon as an organisation absolutely listens to our customers in terms of the wants and needs. We've got in terms of the face-to-face communication efforts we have, our customers have with Amazon. We have people like myself who engage face-to-face with our customers. We've got a 24/7 man support network which has phone support. It does support Skype currently. It also supports Chatter and other things. And this is basically driven by user demand. So as and when users say, do you know what I really want? I want Amazon to go and integrate their support offering with these particular services. We absolutely will. We don't, and we're able to innovate at such a pace. We're normally able to add those integrations in. So it's really all based on customer demand and what our customers want us to do in terms of services.
Great, thank you, Glenn. I think we'll have to cut it short there because we're running a little bit behind time. Any more questions? Yeah. So finally, I'd like to invite Jean Durel from Mobicent to say words.
If you want to open the late from. Welcome everyone. My name is Jean Durel. First, I would like to thank Crocodile for inviting me to the launch of the event, and also being a long-time contributor to Mobicent, of Mobicent Servlet notably. So I'm going to present today what is Mobicent. So Telestax is the leading company behind the open source platform called Mobicent. So what we want to provide is a cost-effective, alternative, and open source middleware infrastructure. So for middleware, it's basically the infrastructure for telecom networks to run on. So we try to provide everything from the what is called SS7 site, so all PSTN phone and mobile networks, up to the bleeding edge and innovation with IMS and WebRTC. So all on open source. We've been doing traditionally middleware, and we run also now into standalone product like SMS that can send SMS, for example. So everything is open source. We have a huge team of contributors, including RCS. Our goal really is to push for innovation through open source and enable companies like Crocodile to push out innovative services. Crocodile was showing where we have a WebRTC app. We've been doing a similar application to showcase how you can use the open source platform to actually build WebRTC application very easily. And for the WebRTC world, since we are coming from the telco background, what we want to provide is bridging WebRTC to the web world with the telco world. So we are bridging those two worlds through a protocol called SIP that's been used in the IMRs for telecom operators. And this is what we provide. So basically, on the web side of things, we provide some JavaScript framework that allows you to communicate with the existing telecom infrastructure, so that you don't need to be isolated in an island to actually talk to the telecom world. So you can bridge to existing telecom infrastructure. And so we use a technology called SIP over WebSockets to allow that, so that you can communicate to the telecom networks, and also not only the telecom networks, but by example, if you want to talk to Crocodile RCS, you can use this technology also to be interoperable with different networks without necessarily being a telecom operator. So we are a big proponent of open standards. So we implement almost all open standards so that you can be interoperable with existing networks. The work on the client side of the WebRTC framework that we provide has been a contribution with Orange Labs. So Orange is a French telecom operator, and they are only contributing to MobiSense and maintaining this project because they use it internally at Orange as well. So we are striving to provide stable and scalable communication infrastructure and components, so that we can really have companies like Crocodile to build scalable networks. On the other side, WebSockets is what I was saying, to provide the web as just another endpoint. When you used to call your telephone number or you're on the mobile, on the old PSTN, we want to show to the world that the web is just another endpoint. So if the user is logged at multiple times on the net, on the phone, or on the web, you can actually bridge this call and try to connect the user, whether he's on his mobile phone, roaming on Wi-Fi through WebRTC, so that you can always connect your users. So I won't go into much detail of the technical background, but for us, it's just another endpoint. We don't necessarily see a difference in terms of infrastructure or SIP infrastructure. We try to bridge those two worlds together so that we can build interoperable services together. An example of that is the video conferencing architecture, where you will see MobiSense SIP Solid being used as a SIP application server. And on top of that, we have an application that's acting as a video conferencing services. And you can actually call it either through the web, to a regular phone, or to what we call a SIP phone IP phone. So really bridging all the endpoints and all the network together to open source solutions. This would look like this, for example, if you want to provide, for example, contact center solution, where you want to bridge multiple people together, then you could build this type of services through WebRTC. So that's a quick, short introduction into what we provide. And it's pretty broad, so I try to focus more on the WebRTC part as part of the launch of Crocodile. Thank you very much. all human.
Thank you, Jean. Maybe anyone has the Crocodile guys.
I've got a quick question. Everybody's talking about using SIP. In the Middle East, a number of governments operate monitoring and stopping SIP. How are you guys going to behave in that situation?
Just open it up and try.
Sorry?
Just open it up and I'm on the device. Skype works now.
Yeah, but not fully SIP. Still monitoring SIP.
Well,
I can actually answer that. Which is that if you actually put SIP over WebSockets and over TLX, they can't see what's in there. They don't know that it's SIP, so they can't block it.
I mean, some governments monitor every so what?
Yeah, it's blocking, more blocking.
Yeah, but the point is it's just an encrypted data stream. Unless they're blocking all encrypted data, you can't tell. It just looks like an HTTPS connection to an online shop. It's over the same ports. So there's no magic way of knowing that this is SIP, and therefore no magic way of blocking it.
But what about the FTP? I mean, SIP simply can't. Yeah.
The media is peer-to-peer, so it actually doesn't go to the.
Why can't they put that? I mean, RTP is going to be.
It's encrypted. Again, it's all encrypted. Yeah,
so one just block. I mean,
well, they'd have to block everything.
They'd have to block all the TLS. Now they could do that, but the point is, you couldn't just, it's not on any defined particular port. It's not in any type of encrypted data stream. So unless they block all encrypted data streams explicitly, yeah. But if they do that, what can you do? If somebody's blocking all encrypted data.
Most Middle Eastern countries are now allowing SIP. The only ones that don't are on the embargo list. You can't say it, but anyway.
The power of the solution also is that even if SIP is blocked, we also provide SS7 open source solution. So we don't really, in our case, we're just trying to provide the means for people to connect. So if they want to use SS7, we provide SS7. When they're ready to go with SIP, we can offer the full path and the migration path to them to actually go full SIP and even provide WebRTC solutions directly.
I will take questions later, I think.
Well, okay, two more.
Interoperability between networks is important. So if I make a port, someone would know the other end would be there. Is that idea? Do I think I can start to phone to someone? You used to go to a telephone network and actually phone someone from browser.
If I take the example of WebRTC, the signaling protocol is not defined, so you can actually use anything. So you can have silos. What Crocodile is providing, for example, is SIP standard. So if I want to talk with Crocodile using existing standards, I can do it. So this is what I mean by interoperability. We're providing a way to actually talk to all open networks that using open standards.
It wasn't very
For clarification, what you're saying is if I want to build a telco and know about all that stuff, we'll use MoSense, SIP servers and things like that, and your technology. But if I was just a basic web developer and I didn't really want to get involved in that telco run, I would just sign up to Crocodile and use your platform to have voice and video and communication into my web app without needing to know about all the telco stuff.
Yeah, Crocodile is hiding all the telecom infrastructure, so you don't have to care about that. You only have to care about your business and the value add you want to provide to your user. So you just use Crocodile network and hope to go and you can really go fast to market with that.
Okay, thank you very much, John.
My pleasure. Thank you.
Okay, yes, I'm not going to say very much. We can't compete any longer against the background noise. But I just do have a few. Well, I should say I think that the common theme from everybody is that WebRTC is here. It's here to stay, and we believe it's going to be revolutionary. So what is it the French say, Jean? Vive la révolution. Say it in French for me. Vive la révolution. Vive la révolution. Thanks. so that's the end of the formal part. I'd just like to say a few thank yous. First of all, I think we have to say thank you to Google. I understand now why they can't afford to pay their taxes. You know, they can't even afford to build us. But seriously, I think we do owe a big thanks to Google. They do a lot, and they do a lot directly. For instance, the use of the facility here and the room tonight is free. Thank you, Aaron. And I'd like to say a big thank you to Randy Resnick for arranging the streaming and bearing with us with the technical difficulties. Ben, I loved your story about the two pizza team. Me and Peter had a real chuckle about that because the whole Crocodile team was in the office last night at 9 o'clock, just getting the demo to work. And we sent out 2 pizzas. We demolished them in about 5 minutes. So that's how long it takes to get 2 pizzas. But I would like to say a big thank you to the Crocodile team. Last year. What we have done is incredibly complex. There's a lot of different systems. We have world-leading expert technology companies. So, can I just ask the Crocodile people to stand up, please?